Now our motto determine V naught with the help of Thevenin's theorem. Okay, so how can determine? How can achieve this target? First of all, if this one is consider X and that is Y, and so 1 kilo ohm is behave as a load resistance. Okay, 1 kilo ohm behave as a load resistance. So find first of all this whole circuit converted according this whole circuit converted corresponding to XY terminal into Thevenin's equivalent. Okay, so how can do? First of all determine VTH. Okay, our motto VTH means V of OC, sir, open circuit voltage. Open circuit voltage corresponding to this one. So first of all this one remove and determine VTH. Okay, so that is (2ix). This one is 1 kilo ohm. Here minus plus 12 volt, and that is 1 kilo ohm, and here Ix. So and that is plus, and here minus V of OC. Our motto determine V of OC. Okay, clear? So our next target is determine V of OC. So how can determine? Now if we consider here, this one is a ductum node, okay, and that is V1 voltages. Apply here I1, here Ix is given, so Ix. Apply KCL at that node. Then we got 2Ix plus I1 plus Ix, this will be equal to 0. So I1 plus 3Ix, this will be equal to 0. I1 is written V1 minus 0 divided by 1 plus 3 into, what about Ix? Ix is V1 minus 0, current leave from positive terminal, so plus 12 divided by how much? 1 kilo ohm, this will be equal to 0. So that is 4V1 plus 36, this will be equal to 0. So V1 is minus 9. 36 by 4, that is minus 9. Clear or not? V1 is minus 9. So our motto determine this voltage, because of this one is parallel to this one, that's why. No current flow from here to why? Because of this open. So we have focus on this current. So what about I1? Ix. Ix is written as V1 plus 12 divided by 1. So V1 is minus 9 plus 12 divided by 1. So Ix is, we got 3 milliampere. Okay, Ix is 3 milliampere. Now next target is apply KVL in this loop. Current flow from, so apply KVL in this loop, minus to plus, minus V of OC. Minus V of OC is, that is 0 voltage because open, that's why no current flow from here to here, plus 1 into Ix, this will be equal to 0. So V of OC, this will be equal to, Ix is 3, so that is 3 volt. Vx, it is also called VTH. Our next target is determine RTH. So how can we determine RTH? First of all independent source reduced to be 0. Okay, it means that is short circuited. Okay, after that this one is make 2Ix, here 1 kilo ohm, here 1 kilo ohm, after that is 1 kilo ohm, here our motto determine RT. So you can consider here 1 ampere volt current source or 1 volt voltage source. If you consider 1 ampere current source, then our mode to determine V. Okay, our mode to determine V. I know that why V is equal to I is 1 into RTH. So basically RTH is nothing, that is V. So if you determine V, then we got RTH. Okay, so how can we determine RTH, or you can say that how can determine V? If you consider here, this node is 0 and this one is a V1, so this one is also V1 because no voltage drop between these two, that's why. Now what about current in this branch, that is Ix, and if this one is I1, so incoming current at that node 1 this is equal to 2Ix plus I1 plus Ix. So you can say that written here 1 this is equal to 3Ix plus I1. 3 into Ix is written as V1 divided by 1. And what about I1? I1 is also V1 divided by 1. So that is 4 V1 this is equal to 1. Okay. So V1 is written as 1 by 4 volt. V1 is 1 by 4 volt. Now our target is apply KVL in this loop. Minus to plus minus V plus 1. Here 1 kilo ohm, that's why we have considered 1 milliampere. Not, we have considered always 1 milliampere. Okay, because in all resistance are in kilo ohm, that's why. So 1 into 1, that is 1 volt, plus V1 is 1 by 4. This is equal to 0. So V is equal to 1 plus 1 by 4, that is 5 by 4. Clear? So what about RTH? RTH is finally, you can say that is 5 by 4 kilo ohm. Now next target is make the circuit plus minus, here RTH and here RL, here VTH, here RTH. RTH is 5 by 4, that is 5 by 4 kilo ohm. What about RL? At RL is 1 kilo ohm. And what about VTH? VTH is 3 volt. VTH is 3 volt. So next target is, what about V0? Our mode to determine V0. So V0 is written as 3 divided by 3 into 1 divided by 5 by 4. It is also written as 1.25 plus 1. So 3 divided by 2.5. So we got 3 divided by 2.5. 3 divided by 3 divided by 2.25, that is got 1.33 volt. That is 1.33 volt is the final answer. Clear? So how can I achieve this target? First of all, we have considered that is RL load. Okay, we have considered X and here Y, and this one is RL load. After that, whole circuit converted into VTH, determine VTH with the help of, if this one is an open circuit, then determine V of OC, that is 3 volt. After that, determine RTH with the help of KVL, KCL, and determine RTH. These value put here and we got V0.